everyone, back to another episode of Reliability BoomBox, proudly brought to you by Reliability Extranet and group of companies, with myself, Dane Sullivan, and our co-host, Seven, aka Peter Horsburgh.
Hello, everyone.
Nice to have you back, Seven.
Thank you.
So, as we like to sort of do, and as I would say I like to do, when we have these fireside chats, I like to leave you unprepared as possible, and just sort of throw things at you.
Throw it at me. Yeah. I love it.
But the last couple of episodes, or the first few episodes we've sort of done a bit of the whys, the whats, the whos, what if sort of thing for problem solving or root cause analysis and machine learning. Mm-hmm. So we could dive into a recap of that, but what came to my mind a little earlier was that maybe it'd be worth talking about some really good results that you've seen from both these situations.
Yep.
And from your experience, because I think like we can talk about the whats, the whys, the whos, and it sort of does give a really good example. Though I think if we just sort of do a bit of a review on maybe if you can just think of a case that's come to your mind, we do a little bit of a sort of a case study and just talk it through and show a really good result of something that has come up.
Yeah. Awesome. So here we are, the $50 million question.
Yes. So let's dive into problem solving first. Root cause analysis. It's kind of been our theme. We do problem solving first. So can you, or do you have one that comes to mind that has presented really, really good and had some really good findings, and just how the framework has helped you through that process? So I guess maybe let's just talk about the case. And the case that first comes to mind that you've got. Give a bit of a background to it.
Yep. A bit of background. Yep. Perfect.
Yep.
So there's been on the problem solving side of things over my career, but I've actually got a couple here, and I'm going to come in from a couple of angles. So one, I'm going to come in from I'm going to give a business related one where there was a positive result with regards to, let's call it bottom line. Okay.
Right. Fantastic.
In a business. And I'm going to talk about another one that is more people orientated and bringing the team on board. And what I'm talking about there is team, as in corporate, all the way down to people working on said piece of equipment that's been causing trouble. So I'm going to take from two angles with regards to the problem solving.
Yep.
Okay. So the first one, business related results. So what was happening was that I took a job. Mm-hmm. Took a job, and the job was related. I got the job because of my reliability experience, and essentially it was a production process. Okay, and the production process was not performing. The production process was not performing to the point where it was actually starting to cause the business a significant problem, to the point where the CEO was getting CEO attention. Okay, so
right.
Chief Executive Officer attention that we've got to fix this. So when I took the job, I didn't know the problem was that big. But anyway, it soon came to me, or a realization to me, that the guys and girls didn't have a method of problem solving.
Right.
Okay, so they didn't actually, they solved problems, right? And the plant eventually went back, but then it would stop again. Okay, and it was a whole heap of little things that are happening that when you summed it all together, was causing this big business problem. Okay.
Yeah.
So, and there's like, and I said a whole heap of little things. There's a whole heap of little things wrong with their processes. Okay.
Mm-hmm.
And that would manifest itself into downtime of, short, frequent intervals in a mixture of large problems, large problems that stop the process for a long period of time.
Sure.
So, after doing a little bit of habit 1 identifying, we went to habit 2 and understanding. And of course, the response was that people said that we understand the problem, we can solve problems. And yep, I get that. I get that. And the engineers love to work as individuals as we do. No, not engineering, And the team wasn't necessarily on board, and the team knowledge wasn't necessarily used. Okay.
Right.
And, when we teach problem solving, we talk about rules when we should kick a problem solving process off. Okay. So a trigger to say, right, I've had a problem that's not this big, but this big. So I now need to trigger a formal problem solving process because this problem is significant. It is, it's crossed the threshold. It's caused a level of pain that that's, I'm going to say, intolerable. Okay. Mm-hmm. So we're having these events mixed in with a whole heap of little events. Okay. So if you can imagine a production process that wasn't simply keeping up. And so we implemented some rules. And one of the rules was when we had a period of downtime that exceeded a threshold, we would do a formal problem solving process together.
Right.
Very important word. Together.
Yes, together. Mm-hmm.
Okay. And so what I did was bring some structure around that. So we did, some steps, and we, gathered evidence, wrote down what the problem was, and then we analyzed the information using some different techniques. And, 5 whys was in there, fish bones was in there, a psychological process was in there. There's depending on what the problem was, we applied different processes, but the message is that it was a formal process that we followed.
Right. Mm-hmm.
Okay. And so lo and behold, we'd catch up weekly, and lo and behold, what we were starting to see is that we're starting to knock off these really big events. And now we're like, if you could imagine, the peaks were taken away.
Yeah.
And then we were starting to deal with all these smaller events that people weren't getting to. They were just sort of put a Band-Aid on something and fix it and get it going, and not actually think about the cause of the problem. Okay.
Yeah.
And that's what using a problem solving process does, is it makes you think about the cause of the problem. And if you can solve the cause, it won't happen again. And so things weren't happening. Things weren't happening again. And our general rule of thumb was that we wanted to do 1 to 2 RCAs a week with the team.
Mm-hmm.
Okay, 2 at the most, 1 on average. Okay,
yep.
And these big problems started going away, and we had to change the target. We had to, let's call it, lower the bar, not raise the bar. We had to lower the bar because there was weeks there that we didn't trigger an RCA because we had solved all of these big hitters. Okay.
Mm.
And then what started happening was that we started catching up. The production process started keeping up with the rest of the business. And as we continued, and again, this process took a number of months. I'm not saying you can do this overnight.
Yeah.
I profess to that. It took a number of months to actually turn this process around. And then within a number of months, we were stopping because we were full. We couldn't store any more finished product.
Mm.
We physically couldn't do it. Okay. And our customers couldn't take it. And so that led to another opportunity of actually rejigging the whole maintenance strategy, which, right up my alley, being the reliability engineer, and it just opened up that whole thing. So it went from a bad news story. Okay, implementing some triggers and a formal problem-solving processes.
Yeah.
To a good news story, to the point where we had to rejig the whole maintenance strategy. We took the advantages of the time that we now had, because the production process was doing what it was originally designed to do.
Yeah, awesome. So if I can sort of just recap on that and what you've shared, is with this role that you had, the problem was quite large. It was quite a financial challenge. Yeah, like they weren't producing enough. They weren't making budget. They were always overrun. Things were breaking down. Maintenance work basically probably wasn't all getting done. I'm making some assumptions here, but all these issues, and whilst all of them could have been quite small, they were just consistent problems that people would put a Band-Aid on and sort of fix. By developing a solid root cause analysis or problem solving process and being consistent in that process, in application and doing it as a collective, so you're not just using the one person's mind. It's not going, okay, Johnny, you're looking after automobiles, so you're going to do all the problems on the automobiles and you just fix them and we'll just leave it to you. You're working together, so you're getting collective, so you're getting a different view on things, and you're getting people to work together, which also incorporates a little bit of accountability there.
Yes.
Because when we work individually, it's very easy to go, yep, I've got these things to do, but someone needs me over there, so I'll go and do that because it's easier. Because it's easier to go and do that than to deal with a big problem that we got there and sort of push away. But we can dive into that another day. So through that, you started to chip away, solve these problems, solve the bigger issues, and then get to the stage where, like, we don't have anything that's causing us to trigger an RCA. Like, because usually, like we've talked about in this before, RCAs usually set a trigger or a KPI. Go, if this happens or this situation occurs, we complete an RCA to identify that problem. What we've talked about, we can do RCAs for anything, just about. The problems can be quite small, but generally as a business and an organization that's suffering such a challenging or harrowing, really, condition, the KPIs are often set relatively high. It's mass loss of production, mass loss of costs or revenue and other things like that. The bringing that bar down allowed you to fine tune that, and then to actually remodel the whole maintenance strategy, because you built up stock, you fixed the plant. In turn, you solved all the problems. Now, in turn, you've created a new problem for the business, but it's a positive problem instead of a negative problem.
It was a good problem to have, and a problem that those guys in that particular case hadn't had in a very long time. So they used to talk about, we used to, the plant we used to fill the place up, and that was the good old days, and it doesn't run, the plant doesn't run like that anymore because we haven't done this, and everyone was, there was always theories and postulation about what was causing it.
Which is a really interesting point, because I'll try. I'm pausing momentarily because I'm trying not to get caught in my digressions too much. Though that, to me, is one of the challenges that we've had with industry. With industry here, particularly in Australia, as long as I've worked, there's always been the tails. I worked with guys that, were 40 years my senior. It's like, back when we used to do this work, it was only on weekends, and we never had to work a public holiday. We never had to work, this maintenance stuff was only done on Saturdays, and that was it. You always had Sundays off, blah blah blah. And now we're pushed to this world of go go go. Mines operate 24/7. They operate Christmas Day, Boxing Day, half the time.
Yeah. Well, I used to work in an industry. If you shut the thing off, that would be really, really bad. Like you run it 24/7.
Yeah.
You know.
Yeah. And yeah, I remember being a manager of a company and having to negotiate with my staff to work Boxing Day. You know, to drive 8 hours to work Boxing Day. You know, and it's like it kind of, now as I sit back, living my life constantly around my family, it kind of make me think, what was I doing? Like taking this away. But I guess I'd bring that back, and the reason I pause for my digression is because I know that's certainly one of my soapboxes I could get on. And I think there's a lot of things to unpack in that. It's not just my learnings, but I think the industry could learn from it.
Yeah.
What you've kind of proven is that if you actually develop a solid problem-solving method and understand the problems well, you can actually improve the business, the overall business, so well that you actually get to go back to that style of living and working.
Yeah, exactly.
You know,
back to the.
we can actually recognize. Go, please.
That way of operating.
Yes.
That way of operating. Yeah. It's, you know, and it was awesome when we sat down one day and I said, look, when we first started all this is what the world looked like, and I just did a comparison. I said, this is what we were talking about all those months ago.
Yeah.
And then I said, this is what the world now looks like, and they said, wow. You know, it was like a wow factor type thing.
Yeah, which I think is really wonderful, because what I have seen with RCAs and problem solving, when done well, and in this situation, because you actually go through the process of understanding everything, documenting the chain of events, you understand the situations and the results of those situations, and you understand the whole problem. In a very short period, you can get at what it used to be and how it is now. You can actually identify that within a number of weeks. Like once you've completed the RCA and you're like going, okay, and actually I can even recall another RCA that you've been a part of recently where they have actually done that. They've actually identified, this is the problem that we've had now, and this is what it used to look like, or it should have looked like. And you realize that for so long we've been doing it this way. Oh, hang on. Now if we change it, and we'll go that way.
Yeah. Yes. Yeah. Well, that leads. I think that's the one that I was about to lead, where we bring the team along. Well, look at that. We get
segue.
Yeah, segue.
This is tea, by the way, everyone. It's just caffeine-free tea for night times.
Oh, very good. I might.
Just in case anyone thinking it was beer or wine, but it's not.
Something alcoholic on the podcast. It'd be terrible.
Not yet.
Not yet. Yeah, and the other thing, like with that whole team and bringing people along on the journey, by following a known process or a structured process that introduces the information in bite-sized chunks. Okay, and one of the things over the years is that everyone that I've learned over the years is everyone has had their own unique experience.
Yeah. Even
with the problem at hand, they've got their own unique experience and an interpretation of that problem. Now, us as engineers may assume that people don't get it. And I've been frustrated. And look how much hair I've got left, pulling my hair out at people that don't get it. Okay, and you know, and I've had like numerous people that I meet on my travels say that, oh, you're an engineer, you're different. Yeah, we are. No, okay, we're different. All right, I get that. Okay, but the interesting thing is that we as engineers have got to bring a whole heap of people along on the journey. So we're to bring the technicians along, okay, so the people doing the work, we've got to bring the technical experts along. We've got to bring the managers along, because they're obviously the ones that ultimately make the decision to spend money, okay,
Yep.
based upon recommendations as engineers of what we should do. And this leads into this example where there was a really big problem. It was really, really big. It had multiple hooks. The thing had multi-year history of causing problems, multi-year history of people doing things to this particular piece of kit, where I'm going to use the words, things were not necessarily correct, but were deemed to be the right thing to do at the time out of necessity. Okay, out of necessity, and you know, if we went into detail, people like engineers like me would simply cringe at some of the things that people did, but it was out of necessity, and it was out of, you know, they were moving forward with the best information they had at the time. Okay?
Bound of rationality.
and the interesting thing was, you know, we got all of this information out. We followed, again, a formal problem solving. We got all of the information out on the table. Everyone had their say. Everyone talked about their experience. Okay. We distilled it down into in this process. It was a beautiful Sologic process and course tree that was understood by all. And I can remember me being the facilitator, standing up there, and I think it was one conversation by one guy in a response to a formal question, as in a question that you ask in your problem solving process, that the whole room, the whole body language just changed. And it was like, you know, the crossed legs, I don't understand type thing, to, I understand, like, and like the whole mood of the room instantly switched, and everyone sort of had that aha moment, to the point after the facilitation session, right? People were coming to me and saying, we now get it, and I can see everyone else on the team now gets it. Yeah. And subsequent to that, once the final report's gone in, of course, the final report is in a predictable format. People can understand it, and you know, the corporate guys had minimal questions about what we'd done, and you know, I'm not privy to the business decision making, or where they're ending up with what we've found and what they're going to move forward with. There's a whole heap of different options that they had to consider. As a result of this, and you know, it's not, and we're not talking chicken feed on this, we're talking multi-million-dollar type decisions, and the corporate guys had 2 questions, and that was it. End of conversation.
Yep.
And they were, and this particular gentleman with the tick wasn't even there. Wasn't even there. You know, and he's in the upper echelons of this particular organisation. You know, okay, he'd be the one that's signing the bottom line on a large multi-million-dollar decision, which is awesome.
And I think that's, I think it's really great to see that a process, a framework like this has been able to go through, identify, have everyone understand the problem, understand the situation at hand, dive a little deeper into it, and then come up with the solution, and all appear at the same point and recognize that this is the key solution. This is the root cause.
Well, there's
causes.
Causes. I don't like causes. I like causes.
Yes.
Like, we understood the causes of the situation, and there was multiple in this case.
Yeah.
You know, and it led back to years ago. Some of these were the root of the problem, or root of some of the problems happened years ago. That was outside of the control of the current people, but now they understand why they're getting the symptoms that they're now seeing because of these causes.
Yeah, which is a really good point, because it seems like in this process, in this instance, for many years, it was obviously a critical piece of equipment that they needed to run.
Yeah.
They really needed to keep this thing going. So they had to put as many band-aids, patchworks and bits and pieces on to sort of keep it going. And with the time pressure situations, they obviously did the best they could with the information they had. The effect of that, which is another interesting topic in this realm, is that information sort of sticks. It's like, well, last time it happened, we did this. Why? Well, it just worked, so we might just do it again. And they might repeat this pattern or this new habit or new action to get them going without actually having dived in to understand. So it comes to the point where now, when you actually finally formalize that process with a framework to establish and really dive into all the aspects, all the realms of possibility, you then can key point a number of different factors, and you can identify where along the timeline in the past some other choices have been made that may have not been best. You know? And you can accept it and go, okay, well, that just happened and that was fine, but now let's move on. What should it really be? Or what would be a better solution? Like, we don't have to just keep doing the same thing. It's like Einstein said, I'm butchering it, but, doing the same thing time and time again, expecting a different result is a sign of insanity, right?
Yes. Yeah, exactly. I think it was Einstein that said that.
Yeah.
So I totally agree. And it doesn't have to be major changes that you're looking at. It could be a subtle change into the way that you do things, and it can make all of the difference. And I think Ron Moore talks about the bow wave. You've got to make this little investment to get that return. And and I think the investment for me is formalize your problem solving. It's not hard. It's not hard.
I think too, what's nice about the formalized problem solving, as we've spoken about in previous episodes, is because it's something that anyone in the team can necessarily do. Anyone can be a part of. You have the ability to bring the whole team along.
Yes.
And this is a really good case of it, because you had, recalling the RCA, you had technical experts that were all over this machine like it was their own hand, or they just knew every part of it. You had technicians that maintained it and that were saying, well, this is what we did last time, so we're doing it again, like this is what we should do. You had engineers, you had supervisors, and then you had yourself that, whilst you got a mechanical engineering background, you probably hadn't seen the piece of machine before.
No. I had an idea. But I didn't know the detail. It was like everything. There's the devil in the detail. But I was not a technical expert in this particular piece of kit. And absolutely not. Even
when you look at your feedback from the upper management member, for him to come back with just 2 questions, having read a report, let's be honest, a lot of people that are managers and so forth may come from a very skilled background, may come from a very detailed process, though he possibly hasn't seen this piece of machinery. He hasn't seen it in operation before.
Hasn't got the experience with it. No.
And maybe hasn't been on the tools in the realms of it for some time.
Yep.
but for him to pick up from the report that there is a clear understanding of the problem, there is a clear identified potential solutions, and there is proof that the solutions will work, or validation that the solutions will work, he can go, okay, we have a solution. And
we got a path forward.
We got a path forward.
We got a path.
What can we do? And
forward.
we can do it.
Yeah. Well, now it's all about how do we achieve this?
Yeah. Awesome. I really like those two examples, and I think they're quite relatable. I think they're quite good examples of how problem solving can really help, and you can build everyone into the team. So moving forward to machine learning. Let's give us a situation, a good one that's nice and digestible. Like I know we say like machine learning is quite new here in Australia, and it's sometimes quite complex and hard to understand. And we know me, I like to simplify things, but I feel like there's one on top of your mind that you can think of. There's a really good example of how machine learning has improved a process or a strategy. Yeah,
well, this is I come back to the whole reason why you look at machine learning from a reliability maintenance sense is problems that we as humans would simply miss. Or we get it when the alarms go off, but you miss the boat when the alarms go off on the machine. So and let's talk about an engine. Okay, and an engine is a complex piece, and it vibrates and things come loose. They do, right? And there's lots of I'm sure there's people out there, maintainers, fitters and electricians, checking things for security, right? Coming loose. So now I'm not saying that you should not do that, but what happens if something comes loose in between your maintenance strategies for one reason or another? I'm not talking about root cause analysis here. We're just understanding that something's come loose, and if we talk about an intake on an engine, right? A turbocharged engine, if something comes loose, like a hose clamp comes loose, or you develop a hole and you lose that boost pressure, you're going to see a difference in a number of parameters on that engine. Okay, you might see you may see a difference in the intake temperature. You may see a difference in the intake pressure. You may see a difference in the EGTs. You may see a difference in fuel consumption. There's a whole heap of different bits and pieces. But the problem that comes to mind is that machine learning, in this case, picked up a loose hose clamp 29 hours of operation before an alarm went off.
Yep.
Right. That one is one that I've been obviously personally involved in. On a rather large engine powering a rather large piece of equipment. Imagine if you had 29 hours to plan something in.
Yeah,
that's a day. All right, take the breakdown, or have 29 hours warning. I'd choose the 29 hours warning every time.
Yes. So as soon as you started talking about that, I remembered the situation, and to be honest, it's one of my favorite ones to use as an example, because it is so simple to explain. It is so straight up and understandable. I'm going to play a little devil's advocate here, though, for a second.
Go for it, mate. I'm going to love this.
Wouldn't it be normal, though, that the alarm is picking this up? So correct me if I'm wrong, but this particular piece of machinery has a bunch of sensors, and it has an alarm that says before anything goes boom, which is what we kind of talk about, it has warning, an alarm. And like, what was that alarm signal? What time frame do we get from that alarm? And then what's the sort of natural response?
The alarm of the type, which, it was a difference in EGTs. Okay, if you get a significant difference in EGTs, you've got a problem. And basically, if you continue to operate, you're going to put the engine at risk. It's one of those red alarms or critical one alarms or category 1 alarms or whatever you want to call it, where if they appear, you should stop the machine.
Right. Okay.
You got a big difference in it. You got a big difference in EGTs. Exhaust gas temperatures. I'm a pilot, and that's one of the things that we monitor in aeroplanes is difference in EGTs, and one of the little planes that I fly, it monitors the EGTs on every cylinder, so I can see as I'm flying along what the exhaust gas temperatures are on the cylinder, and I control the mixture of the fuel going in. That's manually controlled in this particular aeroplane, and the engine manufacturer will say do not exceed 1400 degrees ET temperatures, and I can see that. I can see where each cylinder is at, and if something starts getting hot, my response is I richen up the mixture. If it gets too bad, I'm looking for a place to land. So in this case, coming back to the machine learning, it picked up the subtle differences, not only in the EGTs, but also in the intake pressure. Right.
Good. So this is where I wanted to go by posing those questions. Because again, it's understanding, right? So if we're understanding the problem that was presented, we get to play devil's advocates, because machinery all has alarms. Like the bus I drive and live in has alarms. It gives me little engine warnings, which actually honestly tells you near bugger all, but take it to a mechanic.
Well, you get a difference in EGTs. What can that be caused by? It could be a whole heap of different things.
List is very long.
The list is very long. But you go.
So if I can just identify a couple of key points here. So usually when it gets to the point of alarm, would you say the difference in EGT temperatures would be 5 degrees or 10 degrees or
no.
20, 30 degrees once that alarm hits? Let's just be clear for
it's going to be very significant. You're a 50 degree plus.
Right. So we're looking at something, exhaust temperature might be 50 degrees and your other one might be 100 degrees. And it's like,
exactly.
Whoa.
Significant difference.
We got significant difference.
Right. Well, in Fahrenheit, you're up around the 400, in the thousands, the 1500 mark, and in Celsius, you're down around the 700, 800 degree mark.
Right.
That's the numbers on a internal combustion engine, roughly.
Right. Okay. Electrical. Yeah. I'm just looking for the difference. But
it's significant. Essentially, it's like to put it in electrical sense, you've got uneven loading.
Yes, you've got an unbalanced load.
It's unbalanced. It's the engine's becoming unbalanced for some reason.
Which is really
is a really loose interpretation.
Yes, but that's actually where I wanted to go next, because what we identified in the machine learning, or what we're able to drill down into. So let's sort of paint the whole story, and I'll tell it in my terms now of what I recall. But at first glance, we put this machine learning on a data set. We got all the truck's information. I think it was like 200 tags, or how many tags come off that engine? No,
the truck.
Oh, the truck.
It was 100, over 100.
Over 100. over 100. So over 100 different lines of information came in.
Mhm.
We had a known situation. So we had this alarm that went off.
Mhm.
All those pieces of information were coming in. We said, this is where a fault is. And with a couple of clicks, the machine learning algorithm picked up and said, oh, there's signs of this 5 hours in advance. There's signs of this issue. We can identify that temperature's starting to rise on one of the intake clamps.
It was the EGTs that were responding. EGTs, the machine learning was telling us that the EGTs were the one that was responding the most. Yep.
Right. So so there was a difference in EGT. So one of the EGT indicators was vastly different to the others.
Yep.
And we should do something about it, or we should look a little closer at these sections. Then down.
Well, the way that I think the way we could, just to rephrase that, it's behaving different to what it's learnt. So the machine learning algorithm has learnt what essentially is normal, and it's identified that the EGTs are behaving the most different to what it's learnt. But in the same sentence, I should say that it also said there was other parameters that were starting to change as well, but not as significantly.
Right.
Okay. there's a whole heap of stuff in there. I know. Sorry.
No, that's it. That's all right.
Yeah.
I understand where you're going with that.
Yeah.
And it's a really key point. It's a really good point, because the machine learning understands what is normal. It understands that. Let's just talk EGT for a second for simplification. EGT is normally this. They will range between, I know it's not real temperatures, but say 50 degrees and 75 degrees.
Yeah.
They will range. They will not all be 50 degrees at the same time. Sometimes one will be 55, one will be 60, one will be 50, one will be, they'll vary. Okay?
Yes.
Depending on how the combustion engine is working.
Yes.
Now,
load and fuel.
Loads,
and blah,
fuel.
blah, 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 blah.
Yeah.
Yeah.
An array of different reasons.
Yes.
What we were able to identify early, though, was a constant difference that was increasing.
Nailed it. A constant difference that was increasing. Okay.
Yes.
The behavior was deviating as time went on more and more from what it has learnt from normal. Exactly. You nailed it. Yeah. Difference in behavior.
Difference in behavior. So that highlighted to us that, hang on, there's a difference in behavior in this area of the machine.
Yes.
Look a little closer and let's see what we can do. So we went, okay, this is in the engine. The EGT was measured in the engine bay, the exhaust manifold. So we went, hang on, let's look at the engine tags. Let's look at all the information coming in from just the engine. Let's forget about the wheels. Let's forget about the tire pressures. Let's forget about the strut pressure. Let's forget about what's going on in the operator cab. Let's just focus on the engine and look at those tags. So we're able to concentrate on that, which then allowed the machine learning to look a little closer and now identify that shift even earlier. Which then brings us to this 29 hours in advance.
Not quite strictly correct.
Okay.
No. So we're talking about supervisors and lackeys. So the supervisor got it in 6 hours and the lackey got it in 29. But what the difference was there was that we said, because we knew, as you mentioned there, Dane, we knew where the problem was. So we had a loose. So what we did was we said to the machine learning, we had a loose hose clamp at this point in time. Now look backwards and tell us when the earliest point you see the symptoms of that.
Right.
There's the difference. Slight difference. Yeah.
No. Good. Because you are right. I had missed reminding us that we had the identifier. We had the actual. This was the alarm. It turned out to be a loose hose clamp. So I sort of already knew where we needed to kind of target.
Yeah. Yep.
but we were able to deploy a lackey, as we like to term it,
A lackey.
someone to look a little bit closer at that
Yes.
engine bay, at that engine compartment, and identify, mainly focusing on the EGT and EGP, or the pressure.
It was all engine parameters, actually. Like what you
Engine.
said, it was just all engine.
He just looked at
parameters.
all engine parameters and
All
identify
engine parameters.
anything that created this difference. So I guess if you look at the engine parameters, would have had, at point of alarm, all these things are operating abnormally. So
Yes.
that then lackey looked at all these things and said, they're operating normal, abnormal here. Abnormal here, yes. These are, that's the same tag. These are acting
And it's
abnormal.
And it's getting worse.
And it's getting worse.
And it's
Projecting
getting worse.
forward, that is getting worse. We can now go
yeah.
29 hours in advance.
Which
is awesome.
Yeah.
Because then,
It is awesome.
as we've identified, in a world of trying to keep these trucks running, what's the effect of actually pulling one of these things out for maintenance, or stopping a piece of plant, like you talked about in your root cause analysis, like stopping a whole machinery, or even the other problem, the second RCA case study that you had, it was such a significant piece of plant that if they stopped it, it's like, whoa, hang on, we can't stop this.
No, we can't.
We simply can't. It doesn't work. However, in a lot of situations, and a lot of people carrying out maintenance would understand that for trucks, they often have services like short lubes. For pieces of fixed plant, they go and lubricate, they go and check, they do a walk by and check the vibration or general noise. Like you mechanics about the place actually know how the machine sounds. They know when it's not operating properly. And if they have a window, which in this case they did, because on a lot of sites where they have these trucks running 24/7, they actually do have short in-pit services where they re-lubricate things. The truck is parked for 10-15 minutes and they go, quick, let's go and make sure everything's running right. There is an opportunity to tighten a hose clamp.
Exactly. I couldn't agree with you more. There's an opportunity, and your standard mechanic / fitter or electrician, if they know about a potential area to go and look, like we're not talking zillions of time to actually do that when they're already on the machine. Take opportunity maintenance, whatever words you want to use there. That's what this is all about. It's it's getting the works into those opportunity, they call it opportunity maintenance, but into those planned maintenance intervals. So we've got the heads up. There's something about to go wrong. We know it is because we've had this experience before in the past. Our little machine learning algorithm has been taught that this is true and fact, and if he goes off, our lucky goes off, and we've definitely got a loose hose clamp. And so, those subtle differences that the machine learning picks up can be used to our advantage. And that's the advantage. That's the competitive advantage. You get the heads up of things actually happening, so that you can take the opportunity.
And I think like that was a really good example. It was a great case study that like we like to use and we like to share because it's obvious and it's simple. But even if there wasn't that window of a lube and a 15-minute window, they could have gone and tightened the hose clamp, or if it was something a little bit more significant of a problem that needed more attention, it still meant that you're able to actually, you might have had to still pull it out of service, out of operations. And pull it over to the side. But if you've got a 29-hour lead window, this is what we've sort of talked about in the past, it's a lot better than an alarm that says stop it now.
Yes. Oh, yeah. And we used to, like RCM terminology, consequential damage.
Mm.
Right. You ignore the alarm, keep operating the engine, and break something. Next thing, we call it putting a leg out of bed, i.e. conrod goes out the side of the engine, right?
Yeah.
How much are you up for on a V20? If you do that on a V20 or a V16 or a V12 engine in, the 2,000 to 3,000 horsepower class, you're up for some serious coin.
Yeah.
Serious money. Sorry, coin.
Yeah. Yeah. But that's a really good example, because it's giving you that window and that time to actually make that decision with less pressure. So even if we talk about, if you just had the supervisor deployed in that situation that understood what normal operation was,
yes,
right, he could identify, hang on, there's going to be an issue in the engine bay in this period, even if you haven't trained it to what a loose hose clamp is at this point.
Exactly.
He's identifying, hang on. In 5 hours' time, I'm not sure what's going on, but I'm sending warnings to my reliability team, to my staff, that something is array here and there's going to be a possible problem in the engine in about 5 hours or so.
Well, you get. I'd sort of interpret it a little bit differently. In because we knew where the point of alarm was. Right. We knew, so that's how we could get the 6 hours. I think it was.
Sure.
We knew where the point of alarm was. Right.
Yeah.
I would say the words that I would use is, you've got an impending problem. It's just a matter of time.
And what just came to my mind too, though, is the information that supervisor is able to provide about that impending problem and the area of the impending problem.
Yes, you
allows you to make that decision of,
yes,
do I run the risk and do I keep driving it? We have a window. Like, if you would say this truck is actually about to go out of service next shift, it's only got 4 hours left, just go for it. Don't worry about it. Like, let's just see what happens. Yeah, we haven't got alarms yet.
Yeah, we'd be alert but not alarmed.
Alert but not alarmed. Yes, we'd be alert but not alarmed.
We'll be alert but not alarmed, and we'll monitor, right, to achieve the the goal that we need to do. And we've still got warning. We've still got that warning. It all comes down to that warning time. We've got, the alarm hasn't off at this point in time. We have a machine learning algorithm saying I'm noticing significant difference in behavior in these areas of the engine.
Yeah. And
then you could engage the technical experts and say, hey, our EGTs are starting to do this. Our intake pressures and temperatures are starting to vary. I can now see it. The machine learning's picked it up, and now I can see it. What should we do, Mr. Technical Expert? Should we continue to run this engine? And you'll go, oh, well, your EGTs are, within these limitations. Yeah, I'd continue to run it, but next opportunity, I'd pull it up.
Yeah. So you're giving yourself that lead time to actually make a better decision. You're giving yourself more time to prepare. So that might mean going, okay, well, this truck's just about finished its service. We can wrap that up a little bit quicker and get that one going and tag them out, instead of just going, oh, alarm, truck broke down, fire. Let's put it out. What do we do?
You're in firefighting mode. He's got the ute. We need to get out to the pit.
Exactly.
Well, that's sort of stuff.
Yeah. So awesome. Well, I think there's some really good examples of what RCAs can be, or how they can look, and some good examples and some good results too. I think that's really important, because we can easily just do problem solving or do RCAs and hope for the best and think that we're doing well. But when you've got case studies of actual real good results, it actually highlights the benefits and the importance of operating in that form. Likewise with the machine learning, I think that's a really good example. And I was actually so pleased when we saw that, because again, we do use that all the time as an example, because it is so simple. It's good to present it, to make it clear how it can work. And I think everyone I've spoken to is like, oh, really? And it's like that light bulb. It's like, oh, hang on, that makes sense. Like I've spoken to people that have no clue about industry. no clue about maintenance. You know, the baristas, and they're like, "Oh, really? You could identify that quick? That's pretty cool." And it's like, so I think they're really good case studies. Yeah, I think that's good. I think we've done good. I think you've done well to be on the hot seat again, Seven.
Thank you. You always challenge me. He gives me no warning, ladies and gentlemen. He gives me no warning at all. He just asks these questions. None. Yep. None. So none of this is scripted.
I find it kind of gets the authenticity out of it. It really, in my view, and guys, you can correct me if I'm wrong. I know some colleagues of ours will be maybe listening to some of these now soon, so we'll certainly get some feedback. But yeah, like I feel it's really good to just think on our feet sometimes. I think we can over-script, over-plan, over-follow the textbook sort of process. And anyway, I hope you guys do enjoy it. I think we've got some really good case studies. And we'll probably keep talking in this fashion, just about some case studies, about some examples that we've come up with. As we dive a little bit further into the podcast, we might talk a little bit more about just RCAs. I might do a whole podcast just on RCAs, another whole podcast just on machine learning. And we'll get some other people in to talk about their problems. We've got some interesting guests coming up. And common guests too. I think from my experience of listening to a lot of podcasts, we get a lot of big name people in industry and so forth around, which is great. And we'll certainly look to getting a few of them on the show, though. People on the ground doing the work, I think, is always a really good example of how it can be so powerful and how it can be very useful. So with that, I've got nothing else, Seven, unless you have something you'd like to say, share, or do.
No, I'm all good, mate.
No,
thank you.
You're all good. No worries. Thanks, everyone.
I think I'm going to need to go in the corner and have some quiet time now.
Fair enough. Thanks, everyone. As always, hit the like button, subscribe, leave us a review, and share your comments, feedback. It's always welcome, and look forward to seeing you again soon. Cheers.
All right. Thank you.